Now 45th question asks, what will be the value of K when temperature or rate constant when temperature becomes infinite? Now according to Arrhenius equation, the temperature dependence of rate constant of a chemical reaction is given as K is equal to A into e to the power minus E upon RT, where A is called as frequency factor or pre-exponential factor. EA is activation energy barrier of the reaction, R is gas constant, and T is temperature in absolute scale. Now what happens when T tends to become infinite? When T tends to become infinite, this whole expression, that is e to the power minus E upon RT, tends to become 1. So this is 1, and therefore K will be equal to A at temperature tending to 0, which essentially means that all molecular collision tends to give product at temperature tending to infinity. Now let us move to another question, 46th one. We are given the reduction potential of certain ions, chromium, copper, lead, and silver ions, and we are asked to arrange them in their order of reducing strength. Now, the reducing strength is the ability of the ion to, or ability of the element to itself gets oxidized. So it will be just the reverse of the reduction potential. If reduction potential is low, then oxidation potential will be high. So what happens is that the chromium has got the minimum, you can say, or it has got the minimum reduction potential, therefore its oxidation potential will be maximum. Similarly, silver has got the maximum reduction potential, therefore its oxidation potential will be minimum. So the opposite of this reduction trend will be the ability of the atom to get oxidized or element to get oxidized. Therefore the order of reducing strength is chromium is the strongest reducing agent here, and silver is the weakest reducing agent, and therefore the order will be like this. Now in the next question, we are given certain organic compounds, 1-bromobutane, 2-bromobutane, 3-bromopentane, and cyclobromohexane. Now we are asked to find out which one is optically active or can show optical activity. Now for optical activity in simple organic compound, we need to search for chirality, or an atom, a tetrahedral atom where all the 4 groups attached to the atom is different. So here carbon is tetrahedral and the 4 groups are methyl, ethyl, bromine, and hydrogen. Is it clear? And therefore it can have 2 different special orientations which are non-superimposable, which I am showing in this way. Here there is mirror, so we are drawing its mirror image. Even if you turn this thing, these 2 things will superimpose over each other, but bromine and hydrogen can't, and therefore they can be separated into 2 special forms. One can be called as plus and minus, while the other one, they have superimposable mirror images. Therefore the answer will be B. In the next question, it is a simple question. It is asking, if we are polymerizing styrene, what will be the product? So styrene is polymerized in presence of benzoyl peroxide. Now benzoyl peroxide provides radical, so it's a radical polymerization, and we'll get an addition polymer given by this reaction, and this addition polymer is called as polystyrene, which has this formula. Therefore the answer will be